Okay. Peter Engel. I am a solid waste consultant. I graduated from Antioch, I think, Michael, it was like 1987, which now is essentially a generation ago, more. And I've been doing the same thing for pretty much ever since. I've been a solid waste advisor, recycling consultant, composting consultant, waste management consultant, whatever you want to call it. I got into it because my first passion was, environmentalism. It was spurned by, Earth Day and whatnot, things like that. But I got into it through organic agriculture, actually. So I was doing organic farming research on season extension technologies and regional food systems. And I recognized the value and the importance and the critical role that recycling of organic matter plays in organic agriculture. And so Michael and I were working together early on when he was at Antioch, and I was a student, and it immediately kind of light bulb goes off when he's talking about working with starting the first municipal yard waste composting operations in New England, where the leaves that are collected from the streets are being turned into compost. And, so that was it. It was like, okay, this is a place to close the loop. And I had done enough physical work with my hands at that point. I was ready to start using my brain a little bit more. So that was kind of the transition into what I do, and I've just been doing it ever since. So I work primarily with municipal or public sector clients, but it's not all of them. I do work for some of the big names in recycling and national solid waste management. I do work with brand owners, as in large multinational corporations that make consumer products. And pretty much across all aspects of the recovery chain. Not kind of if you've been introduced to life cycle analysis, or you already know it, you have kind of extraction, manufacturing, shipping, transport, sale, consumption, and then, right? I've always been down here at this point, although I've been using that, not quite, it's not a really effective mechanism, but there is a good bit of the stuff that's going on down here, which is trying to influence all that stuff back upstream. And that's would be a presentation for a whole nother day, product stewardship or in extended producer responsibility. So I've worked in that realm as well. So, and nationally and internationally. Right now I'm cranking on projects for Charleston, South Carolina, Miami-Dade County, and Dushanbe, Tajikistan, and Freetown, Sierra Leone. So that's I've been kind of doing a lot of stuff remotely for years, although it's even more extreme nowadays. And it makes a real challenge for the working environment, especially for the stuff that I do, because so much of it is being able to put your eyeballs on it, be working person to person with people to solve problems, to understand their needs, to understand the local situation. We have kind of like across the board saying, which is like, all garbage is local. I can have the same toolbox, right? But every situation is unique. And so that's part of the fun of what I do, actually, is it's solving problems and helping people through that analysis and decision-making process and strategy. So there you go. Let's see. I want to move on. So I'm going to focus right down into kind of one little thing today, but I can't help it because I'm an ecologist by training. is I look at, I recognize that it's taken me years to learn things because I need to be able to kind of see the entire system in order to understand the little pieces. It's like, I can't, I'm, you know, it's just the way my brain works. So we're going to be talking primarily about recycling, materials recovery, and the point in there, which is called the materials recovery facility. It's sort of like the bridge. So, you know, that third point, it's the bridge from collection to commodity. And we'll talk about that, and that'll, you know, kind of that concept will emerge. But I wanted to kind of lay a little bit of a foundation here, or background and context. Why do we recycle? And then what is current in the framework of most of the recycling that we're familiar with here in North America, is where there's this drive to reduce recycling costs and increase recovery. Now that is a common thing, but there's particular aspects of that which are unique to kind of like the North American context or the European context, which we'll be talking about here. Again, if we were to kind of take this whole materials, you know, looking through the lens of, or, you know, looking through, if we were to kind of take our site and look at the low and middle income countries, it would be a kind of a wholly different you know, way of understanding the framework or understanding the drivers, et cetera. So in any case, we're talking about really a North America context here. And then I want to talk about what is the state-of-the-art MRF, Materials Recovery Facility, version 2020. I would say we're probably in the 4th or 5th, maybe 6th generation of evolution of these facilities. And then I want to talk about, do kind of a summary of where we've been. So why do we recycle? Now there's a lot on this slide, okay? But let me just pull out kind of the main points to this. Is there's essentially two kinds of recycling. There's value-driven recycling, which is, like I say here, based on the dynamics of supply and demand. Value-driven recycling is based on the intrinsic value of a material. So this value-driven is the original recycling. Rag pickers in cities, horse manure. The farmers in Paris, around Paris actually, in the 1800s, before fossil fuels and internal combustion engines, would bring their food to market on horse-drawn carriages. They would pick up the manure from all the horses that were in the city, because there weren't any cars, and they would load that back onto their wagon, and they would bring that horse manure back to the farm. They would tuck it into the soil. They would put some glass cloches over it, bells, or, you know, raised beds, and they would have heat, carbon dioxide, and fertilizer. So the intrinsic value of horse manure. Night soil, as in, you know, the stuff that came out of the streets of our towns. Tinkers were a kind of, you know, these were people who would go around and fix materials for people, or they were the original scrap dealers. They would gather metals, they'd melt them down, they would mold them, whatever you do. So now you can think of value-driven recycling, and what you see around you now is scrap metal recycling, cardboard recycling, and high-grade paper recycling. Those are examples. They're being driven by the intrinsic value of that raw material for manufacturing a new product. Now, the other is policy-driven, and that's based on social and environmental and social factors. So if we were to kind of, and this ties down to, there's these two kind of things down at the bottom, and you don't need to understand, you'll have the presentation, you don't need to kind of fully grok it now, but the presentation, that you can take a look at this, and I'll try and help you through it a little bit, just to kind of give you a flavor. That's all I want to do here, okay? is just kind of give you a flavor of this. So you get a kind of a lot of ideas coming in there and let them spin around, right? So policy-driven is based on environmental and social factors. MOBRA was this garbage barge that went it was basically garbage from Islip, Long Island, I think it was, Michael, and Long Island, and it went hunting all the way from Costa Rica to Florida to wherever, and it couldn't find a place to dump the garbage, and ultimately came back. And it was this light bulb that everyone was started going like, wait a second, what the hell? We have no place to take our garbage. There was Earth Day. There was the realization of, like, you know, consumption of fossil fuels, environmental justice movements, extended producer responsibility. We're now thinking about climate change and ocean plastics. These are things that are environmental and social factors, right? And as you go through these, what I would call the bottom left is stages of awareness. And if you look at these stages of awareness in societies, we go from going like, holy crap, we have a problem. How big is the problem? Quantification. We start looking at like, oh, it's not just a little problem here, it's an ecosystem. Then we start thinking, it's like, wait a second, where we put our solid waste facilities is actually having it's having environmental impacts on portions of society which are less disadvantaged. We start thinking, we maybe, because of fossil fuels and climate change, we maybe start to think about squeezing more efficiency out of the system. And as we start looking at climate change and ocean plastics, we realize that everything is connected. So it's also in parallel, there's this process of internalizing costs. That's environmental, that's kind of environmental economy 101, environmental economics 101. So enough on that one. Why do we recycle? So this is looking at it from the policy-driven, answering that, why do we recycle from a policy perspective? Simple concept to, it's just kind of everywhere, if you were in this field. It originally evolved in the mid-1980s, was this concept of integrated solid waste management. That means that you are managing each individual component of the waste stream in order to first minimize or reduce the amount of it that is discarded, that becomes waste. And once it does become waste, then you are focused on maximizing the value recovery and maximizing the kind of the amount that is diverted away from disposal. So that's the kind of the solid waste management hierarchy. It's the bottom left of your screen. It's a standard, reduce, reuse, recycle, recover. We're up to about 6 R's now. Some people have put together these things as opposed to it used to be the 3 R's. Where some folks are seeing it now with 6 R's. Now, so there's the principle of integrated solid waste management, and then there's the process. And this over in the bottom right is something which Michael would be very familiar with. And I don't want you to necessarily understand this, but garbage is human, right? It isn't an engineering problem. It's a human and engineering and politics and economics and public attitudes and social norms, and so many different things get into this that the process of integrated solid waste management needs to take into account a whole systems view. And so here we're talking about you have in the middle, you have the waste system elements. That's kind of the hardware, right? Then you have the stakeholders, who are all the people who are affected or who are involved in the system. Then you have all the various aspects of the system. There's technical, environmental, financial, et cetera, like I was talking. And you're bringing those all together over time and engagement, planning, analysis, et cetera, through a process over time to move towards sustainability. So why do we recycle? And this is Not, again, I'm in the topic, so it's not, I'm still not trying to answer the question so much here, so maybe that's not clear, but it's what I'm looking at here is the principle is that now policy-driven recycling, all wonderful and good, but it ain't worth a hill of beans if you can't sell it. So it's how does policy-driven recycling survive in a value-driven marketplace? You have the laws of supply and demand. You have the commodity prices, which fluctuate due to many other factors. The price of fossil fuels, of oil and natural gas, is the major driver for the price of recovered or recycled plastic. It's got very, very little to do with the recycling system. It's all driven by that raw material extraction cost, because it's the avoided cost that we're looking at. If it's cheaper to use a recycled feedstock versus a virgin virgin, great, they're gonna use that recycled all day long. But if the virgin is this cheap and the recycled is this expensive, it's very difficult to justify that difference. I want to talk about the process of program push and market pull. A recycling program may need to focus its policy, its investments, its networking, its everything on pushing materials on the supply side. There are other times when we're seeing the commodity market, the consumer, not the product consumer, but the manufacturer, who is trying to pull materials through that recycling value chain. So I can talk about some examples, but I think that would maybe be better to go on. And so, but kind of graphically, what we're looking at here is, you know, in the distilled environment of the economic classroom, we look at this beautiful equilibrium price of supply and demand. So anybody who's taken, you know, microeconomics 101, there's your supply and demand, right? You've seen it. Over on the other side is, this in reality is the price history of OCC, which is cardboard, from January 2008 to August 2017. So how do you survive as a business when the product you sell goes through price cycles like this? That's the challenge. So let's talk about kind of a case study very quickly. I hope that everyone has or knows about or has heard somewhere in the press, I can't imagine not, but maybe, about China and the national sword and the fact that China's not taking our recyclables anymore. As a country, they are instituting a policy of, we're not going to take your garbage. We're not going to even, in fact, we're going to start to kind of become much more self-reliant as their local economy and standard of living and the consumer economy begins to generate more discarded packaging. They're beginning to supply their own. They don't necessarily need all of that, the recyclables from North America like they did a number of years ago. So in any case, what China and a number of other the Asian tigers did during the primarily during that era 2000 to 2010, is they built up modern, state-of-the-art manufacturing facilities for packaging and products that were based on recycled feedstocks. So instead of, because there's not a forest really that they were going to cut down. Yes, there is, but you know, but they basically what they said is like, we're going to take all that cardboard from North America in order to make boxes, instead of buying pulp from Northern Europe, from forests of Northern Europe. They did this with state-of-the-art technology, which was able to actually handle higher levels of contamination in the recyclables than the North American markets. And because of state subsidization in China, they were able to and a number of other factors. I don't want to hang it all on that, please. But they were able to come into the US market and say, we'll take it all and we'll pay you top dollar for it. And don't worry about the quality. That created an unsustainable supply and demand dynamic, high price for low quality recyclables. So they were making, as I say, these major investments. Now, China then changes course and says, like, you know what, your stuff is really too dirty. We don't want it anymore. And we're left holding the bag, right? So that's what has gone on here, is where we've got this kind of a supply and demand market that is just going through a tizzy. You know, it's like all of a sudden the demand is like gone from huge demand down to very little demand. And as a consequence, prices have dropped. This down here in the bottom right is the beginning of that in 2017. You see that decline in pricing? That's the cliff. And we're digging back up out of that cliff now, out of that valley, out of that hole, whatever. So what happens in a marketplace? Supply and demand, cheap materials, opportunity arises, and investments are made in the North American capacity to consume recycled material, to consume those recyclables that were once going to China. We're in that market stabilization or that supply-demand rebalancing act right now. So, you know, many communities were asking, why the hell are we recycling? The point that you need to remember, and we advise our municipal clients on this, is municipal recycling is policy driven. Now, it's not just a business. It's being done for a whole host of reasons other than just like to make money. So we are counseling folks to weather the storm, set a steady course, to be able to see your path through turbulent conditions and understand the market dynamics and focus on your just understanding the true cost of recycling, and look at, if you make money at the end of the day to offset some of those costs, call it gravy. Let's see, so let's move on to another one. So, and I'm gonna I think I need to, we've got to end, Michael, at 11, is it, or when?
Yeah, 11 with all the, you need
with questions and things. Okay, well, let's I'm going to slip past this one here. But I think the point I want to make is back on here. The last thing is, how are we to survive in a policy-driven recycling, to survive in a commodity or a value-driven commodity market? So we talk about this, understanding your true cost, but the other thing is you got to focus on quality. Okay. Now, municipal collection and processing facilities have moved from, you can see in this, you used to, let's say you had a drop-off program. You had a curb sort program where a truck would go around. Now, wow, they actually come to my house. But the person on the truck would literally sort the materials into different bins. We had 7 bin trucks, 7 compartments on a truck. That's a lot of time. So then it was like, great, okay, we'll put all the metal, plastic, and glass in one, and then we'll put the paper in another. That's called dual stream. You got your fiber and containers. And then now most of the marketplace, there's a lot of, variations and unique conditions, is gone towards single stream, all those recyclables together. So this has been that evolution, and that has been driven and what we see in that evolution of collection systems is the blue bar, which is the quantity per household, goes up because you've increased convenience. You've come to the house, you give them a bigger bin or a cart, and you provide weekly collection. It makes it and you allow people to mix it all together. That's more convenient. People are more willing to participate. Then you've got like the grade, which is your contamination. So that goes up as your participation rates go up. So essentially what we've seen going on here is what used to be me as an individual going to a drop-off or to a curbside program and having to be responsible for putting the right thing in the right place, that's moved from the generator to the collector to the processor, and even as far as to the marketplace, where you've got those cardboard mills taking all types of contamination and they're sorting it out. So I want to talk about the bridge then here. The MRF is this point in the middle. You have collection, you have the processing, and then you have a commodity which is sold into the marketplace. That MRF is the bridge from the collection to commodity. Economics point to the MRF. Primarily, there's the economic side of this, which is the combined cost of collection and processing in this graph that you're seeing here is drop-off is pretty cheap, right? You've got a very low collection cost and a moderate processing cost. And it's great. You can run it all day long, but you're not going to necessarily get a lot of tonnage. If you really want to push for, and I'm talking about this in kind of the urban and suburban environment, rural recycling or small community recycling is another matter. But you go to a curb sort program, your collection cost goes through the roof. Your processing cost still stays relatively low. Combined cost is probably almost the highest. Dual stream programs, a little less, and single stream, it's compelling to move to single stream for economic reasons. The MRF is the bridge. And this is a snapshot, okay? Basically what we're trying to say, what I'm trying to point out here is the MRF is a manufacturing facility that is reverse engineering the waste stream. And and it is influenced by the recovery cost of the stuff that comes in the collection. In the facility itself, they're trying to maximize quality and maximize throughput, which are two very divergent principles. Ultimately, at the end of the day, they're trying to produce a commodity and a maximum value for that. So the MRF is in this balancing position, or it's the bridge that makes it possible. So now I throw into the mix the evolution of the material stream, right? Drivers across the life cycle, across the supply chain and recovery chains. We're looking at supply chain efficiency, shelf stability of packaging and products. We have all kinds of product branding, and people want to have their own unique shape and their unique color and everything. There is e-commerce, which especially in the last year with COVID has exploded. But well before that, 2 years, 3 years ago, we in the recycling side were talking about the Amazon effect. The Amazon effect is changing the composition of your residential, of the materials that flow through your residence, that flow through your life, right? And we're in this kind of course of materials management. So and you're going to be looking at what goes through your household. Think about what would have gone through your household a decade ago. Think about what went through your household of your parents and how that has changed. So outcomes of these drivers is lightweighting. It means aluminum cans. I mean, it was kind of the joke of people like taking an aluminum can and crushing it on their foreheads. That was something that somebody who had a really thick skull could do. It's not that hard to squish an aluminum can now. Your water bottle is barely, it squeezes, it practically breaks in your hand. They've lightweighted that. We have all kinds of different materials. We have multi-laminate packaging, flexible pouch packaging. We have a gazillion different types of plastic, there's 4 or 5 different types of plastic film. There is, 7 different resin types that are used in plastic packaging. What's happening then is, and think about this from the MRF, okay? The tonnage has gone down, but the volume's gone up. And as you're in materials, the MRF is essentially has to be designed to handle volume because I'm running something down a conveyor belt. If it's big and fluffy, I need a big belt. And I need a, it has to be the depth of burden on that belt, the depth of material, right? That's the volume that I can move through a system is this big and how fast it goes. In the past, I could squeeze, let's say, a ton through that. Now I can only squeeze 500 pounds through that. So that, and at the end of the day, I'm selling my commodities based on the tons, not the volume. So I got to run more stuff and faster in order to produce tonnage. And obviously, as you know, I imagine most of us understand plastics is the greatest point of confusion throughout the recycling system. So I do want to say the rural and the small community is an exception. And we'll talk about, sorry, we can, that's like, that's a great topic for, discussion. So where are we going with the state-of-the-art MRF right now? This is a 3D isometric drawing of the facility that I'm working on. We're getting into the final stages of construction and commissioning for Charleston, South Carolina. And they're complicated. It used to be all you did is you had a conveyor and it went into a baler, right? Because everything was source separated. Everything was clean. It's like the person put their cardboard here, their newspaper there, their, whatever, their steel cans here. All you had to do is pick out a little bit of contamination, run it up a conveyor, and bale it and market it. Wonderful. Not a lot of capital. We have now moved to the point now where a recycling system, this is about $12 million worth of equipment sitting inside including all the site development, $15 million site and building. It has a whole education center, administrative offices. It has a parking lot for all the collection trucks. It has a fuel facility. It has a maintenance bay, wash bay, blah, blah, blah. I think I just said something that added up to $27 million just for recycling for 130,000 households. But this is a facility that's designed to last for 20 years. So let's not say I can do the math here. Let's round it up to 30 million. That's $1.5 million worth of CapEx, capital expenditure, per year over a 20-year life cycle. Not so bad. We're focusing on high throughput using mechanical sortation. We're minimizing the amount of manual labor. That's always been an issue because of having a lot of trained people willing to work in this kind of environment has always been a challenge. Now you throw COVID into that, it's even harder. We're obviously focusing on quality, quality, quality. The point is, even in the worst of the market disasters that we were seeing in 2018 and 2019, because of the national sword, the loss of markets for mixed paper, cardboard, mixed plastics, you would see in the news, people are going to shut down their recycling programs, whatever. Even in the depths of that market, the municipal programs that were producing, or the MRFs that were producing quality recyclables, still could move them in the marketplace. They may not have gotten paid for them, but they could move them. So quality. And then ultimately we need to design for flexibility and future adaptation. It used to be that people kind of like built a MRF and that was it. And they didn't really look to the future. I think we're acknowledging the fact now that these have to be evolving facilities, right? They have to be flexible. So the big picture on the process flow, I don't know if we need to get into do this, but what I can tell you is there's a lot of equipment. You pick out the big bad stuff right up front, and that has to be done manually. Then it runs across a series of like screens, which does the macro separation based on size and dimension. Then we're using optical sorters, high speed, wide belts that use air. They use optical vision. They look at it, they recognize that's PET. They're using infrared, and they're recognizing that's a PET bottle, a plastic, a soda bottle, that's a milk bottle, that's a whatever it is. That's brown paper, that's white paper. And then they use air jets to, and if you sit next to one of these machines, it is just going, They're about 6 feet wide, and they have about 400 little air jets in them. So they're pinging material all over the place. Then we're going to manual quality control. So you're focusing your labor at the back end to do that final inspection and cleanup. And here come the robots. Robots are moving in. They were initially being used at the back end for quality control. And as the state of that technology improves, they're moving up in the MRF towards faster and more complex sorting functions. So kind of as a wrap up, first off, there's many solutions, okay? Garbage is local. Programs and policies. So policy-driven recycling needs to recognize the true cost of recycling, the commodity or the value side of recycling, and understand the true costs to process it. It costs money to process recyclables. Municipalities have to understand that recycling is not a money-making business. It's a business that makes some money to offset its costs. That's an important difference. And also, you have to understand that as you drive to increase recovery by getting everybody to recycle right, all that type of stuff, you have to recognize the fact that you're getting into that 80-20 rule, right? There's 20% of the people who are diehard recyclers. There's 80% who are like, yeah, sure, I'll do it if it's convenient. The more you have of this, the more contamination. Quality is always essential. So you have to invest, not just in the MRF, like that $12 million worth of equipment. You have to invest in public awareness with the understanding that you're not always going to get everybody. And last of all is what we say is you got to address wish recycling. People have to understand that this is not plastic. I don't have one here, but it's a wish recycling. Christmas lights are not recyclable. Garden hoses aren't recyclable. Deer heads are not recyclable. We see them in the MRF. People put them in the recycling bin. It makes a mess. Oh, disc rotors, propane cans. It's nuts. Yeah, sure, they're metal, but don't put that in there. That's good. It's explosive. So in any case, policy-driven recycling in a value-driven commodity world requires a long-term and a steady commitment to that policy. And then you understand it's going to go up, it's going to go down, but just keep a steady course. I think that's it.
Thank you very much. That's a lot in a short amount of time. You want to stop sharing so we can bring the gallery up?
Yeah. Hold on. Okay. Let's see. Where do I do that? There we go. You are screen sharing, and then I do that, and then do stop share. Okay.
Okay.